One of the first concepts is to become acquainted with the data scientist, a relatively new title. It is not readily recognized or accepted by many organizations, but it is here to stay. A data scientist is normally associated with an employee or a business intelligence BI consultant who excels at analyzing data, particularly large amounts of data, to help a business gain a competitive edge. The data scientist is usually the de facto team leader during a big data analytics project. The title data scientist is sometimes disparaged because it lacks specificity and can be perceived as an aggrandized synonym for data analyst. Nevertheless, the position is gaining acceptance with large enterprises that are interested in deriving meaning from big data. The voluminous amount of structured, unstructured, and semi-structured data that a large enterprise produces or has access to. A data scientist must possess a combination of analytic, machine learning, data mining, and statistical skills, as well as experience with algorithms and coding. However, the most critical skill a data scientist should possess is the ability to translate the significance of data in a way that can be easily understood by others. The team challenge. Finding and hiring talented workers with analytic skills is the first step in creating an effective data analytics team. Organizing that team is the next step. The relationship between IT and BI groups must be incorporated into the team design, leading to a determination of how much autonomy to give big data analytics professionals. Enterprises with highly organized and centralized corporate structures will lean toward placing an analytics team under an IT department or a business intelligence competency center. However, many experts have found that successful big data analytics projects seem to work better using a less centralized approach, giving team members the freedom to interpret results and define new ways of looking at data. For maximum effectiveness, big data analytics teams can be organized by business function or placed directly within a specific business unit. An example of this would be placing an analytics team that focuses on customer churn, the turnover of customer accounts, and other marketing-related analysis in a marketing department, while a risk-focused data analytics project team would be better suited to a finance department. Ideally, placing the big data analytics team into a department where the resulting data have immediate value is the best way to accelerate findings, determine value, and deliver results in an actionable fashion. That way, the analyst and the departmental decision makers are speaking the same language and working in a collaborative fashion to eke out the best results. It all depends on scale. A small business may have different analytical needs than a large business does, and that obviously affects the relationship with the data analysis professionals and the departments they work with. Different teams, different goals. A case in point would be an engineering firm that is examining large volumes of unstructured data for a technical analysis. The firm itself may be quite small, but the dataset may be quite large. For example, if an engineering firm was designing a bridge, the components of big data analytics could involve everything from census data to traffic patterns to weather factors, which could be used to uncover load and traffic trends that would affect the design of the bridge. If other elements are added, such as market data, material costs, and anticipated financial growth for the area, the definition of a data scientist may change. That individual may need an engineering background and a keen understanding of economics and may work only with the primary engineers on the project and not with any other company departments. This can mean that the firm's marketing and sales departments are left out in the cold. The question then is, how important is that style of analytics to those departments? Arguably, it is not important at all. In a situation like that, market analysis, competition, government funding, infrastructure age and usage, and population density may not be as applicable to the in-place data scientist.